at all this. Okay, so test will be either Wednesday or Thursday, second period Wednesday, Thursday, fifth and sixth period, unless you have a problem with it being Thursday because of church night, even though we're not going anywhere, then you can take it Wednesday. That's up to you. But you have to let me know that in advance. I am just going, because of it pulling different questions, I think I'm just going to say it's going to be open and you'll have like a 90-minute time limit on it during that day, and not worry about taking it during the class time, because that made a massive mess for me last time. So with pulling different questions, I feel somewhat safe in doing it just an hour and a half during that day. If I make it longer and feel like it needs more time, I may give you up to 2 hours on it. But that's just going to be the general setup for that. Other stuff, I think, okay, so we all got the announcement about school stuff, yes? This will be how we see each other for the rest of the year. I am not enjoying that. However, if it means we can go back to school in the fall, I'll take it. And that's where I'm kind of seeing things. I have not yet explained to my 4-year-old that she doesn't get to go back to school at all. This is going to be something that I try to avoid. It's excellent. My 2-year-old's thrilled about it. She didn't want to go back to school, so she loves this. Anyway, so because of that, and did you all get the email if you're in dual credit about no dual credit exams? So no exams at all, period. End of discussion. For dual credit, this is our last test grade. So your dual credit grades are finalized like after this one. We have 2 more like mini units to cover in pre-calc, but those are prep for calculus. They are not part of the dual credit curriculum, so they won't count into that. So if you do have dual credit questions about your grade and what it's going to end up being, it's really just going to be an average of quarter 3 and quarter 4 for this semester. Take the 2 of those, 50% of each, since there's no exam in there. And remember that dual credit is just a letter grade. So if you get a 90 to 100, it's an A. End of discussion. That will also include test corrections on both of these. However, I decide to count those in. So if you have to do test corrections for Unit 8, those are due by this Friday. And if we have the next ones, we'll get those in the next week or so, because I'm not due for grades for dual credit now because of all of this until like the first week of May. So we have a little bit of time. But yes, speaking of extra time, like I had built in time into our schedule for like dual credit review, dual credit exam, losing everyone to an AP test. So things may be a little bit interesting scheduling wise. If we have AP tests coming up, yes?
Yes, ma'am.
How much of our time, like, what weeks are those? First week of May, second week of May?
I know I have one like the 14th and the 15th, and then one the 20th, I think.
Oh, wow, those are late. Okay.
Roll back a week.
Okay. Oh, they did. Okay. Well, that's good to know. I need to look at those because I was going to say that we may take this Friday and next Monday off, just because we're kind of ahead of the schedule with not losing days. But I may just keep powering forward so that I can give you some time off around AP tests. Is that better?
Yes, ma'am. That would be great.
Okay. So
that would be great.
Yeah, I'll just go ahead and start into limits then. So, and for seniors, any seniors listening, what do they tell me? Your last day is like May 13th, I think is what they said. So seniors are, for me, you guys have always been responsible through Unit 9. So if I get Unit 9 stuff done before the 13th, seniors, y'all are just going to be done. Juniors, you're going to stick with me through Unit 10. Unit 10 for us may be more of a fluid, like, here is the Unit 10 information. When you feel like getting it done, it will all be due by like May 22nd, whatever that is, and we'll be done. But if you get it done earlier because of your AP tests, we'll be done earlier. So that's kind of my plan here. I'm mapping out stuff for the next 4 weeks, now that we have our final answers on everything. So that is the plan. That will be our good plan going forward. So let us discuss homework questions then, and then any other things. And there are a few quiz questions that I wanted to talk about as well. Just things that I noticed, as well as the challenge problem. So for homework began on 266. Did we have questions on 266, 267, 1 through 8?
For number 2, I ended up simplifying that to cosine equals 0 and 1 minus sine equals 0. So I got 2 answers instead of yours, I believe, only had only 1. And that's because it didn't have the cosine. So I don't know what I did wrong for that.
Let's talk about that. And that's actually one of the ones similar to a quiz question as well. So some of them that have the reciprocals and stuff get a little bit tricky because of the whole denominator thing. So if I was solving something like question 2, I would have changed secant into 1 over cosine, and then I would have changed both of my tangents and cotangents to sine over cosine plus cosine over sine. And I would have gone through and solved this probably in this case because of the fractions. I would have multiplied everything by both cosine and sine to get rid of all my fractions. So that being distributed to the first term would give me a sine. That being distributed to the second term would give me a sine squared. And that being distributed to the third term would give me a cosine squared. So sine squared plus cosine squared changes into 1. So I'm looking for where is sine equal to 1. So sine is equal to 1 only at 3 pi over 2. However, you kind of have to see if you can get answers in the original problem from that. So going back at 3 pi over 2, I would check, do I have secant values there? So at 3 pi over 2, that's the reciprocal of cosine. You get undefined, so it's a little bit iffy on that one, but it's better than nothing. Tangent at that one would be, tangent at 3 pi over 2 would be sine over cosine. That would also be undefined. Cotangent would be 0, so that would work out fine. But where else did you say you had answers for that one?
I got pi over 2 because I simplified at the beginning to be 1 over cosine equals 1 over cosine, like cosine and sine.
Okay. So you got a common denominator on the right-hand side?
Mm-hmm.
Yeah, let me go back and look at that. So you have 1 over cosine, and then you had, so you did have to do tangent as sine over cosine and cotangent as cosine over sine, but then you got a common denominator of cosine and sine. So you ended up with 1 over sine times cosine.
Yes.
And then where'd you go from there?
I did the flip thing that you did, so then I got cosine equals sine cosine.
Okay. And then moved everything to one side, greatest common factor?
Mm-hmm.
Okay. I don't actually see anything wrong with that. It has to do with the fact that I've got sine equals 0 and, not factoring out a sine, excuse me. It has to do with the fact of the cosine being 0 on the bottom here. So if you factor out a cosine, you've got sine minus 1. These answers from cosine equaling 0 get eliminated because of this right here, the representation of secant, because the cosine is equal to 0 on the bottom. So when you essentially set this equal to 0, you're saying cosine equals 0. Well, what are you not allowed to divide by right there?
0.
0. Sine equaling 1 is fine because that doesn't mess with the bottom, but cosine equaling 0 is a problem.
Question.
Yeah.
Where do we get 1 over sine x cosine x?
That was from, she made tangent, sine over cosine. She made cotangent, cosine over sine. I was skipping a couple steps there. She then multiplied the first fraction by sine over sine, second fraction by cosine over cosine. So
Okay.
it gives me sine squared plus cosine squared over a common denominator of sine cosine. And that's where the 1 comes in.
Okay.
Okay. Other homework questions on this page?
We're still not putting 2 pi, right?
Yeah, don't put 2 pi. I need to edit those keys, but no, don't put 2 pi.
Okay.
So, because 0 includes 2 pi, and that's fine. You don't need to worry about that. So,
We do put pi though, correct?
you do use pi. So it's really just anything 0 up to 2 pi, but not including 2 pi. And that's only because 0 and 2 pi are exactly the same. So you don't have to, it's essentially including the same answer twice. So you don't need to. Other questions on this page, this set?
I had another question.
Yeah.
So for number 3,
Yeah.
I got it to sine, then parentheses 2 cosine squared minus 1. And I changed that to just sine cosine. Am I not allowed to simplify it that way?
Let me just see. So we changed sine of 2x to 2 sine cosine. Multiplied by that cosine makes that cosine squared. And then you took out a greatest common factor of sine. That leaves me 2 cosine squared minus 1 equals 0. And then what did you say you did from there?
I changed the 2 cosine squared to just cosine 2. Just
The whole thing, cosine 2x there. Yeah, you can do that.
I realized my mistake. I didn't change it to 2x. I just did that.
That's why then. Yeah, if you want to change that to cosine of 2x and then solve that, you can. I kind of found it easier to solve just by using square roots from here and setting that equal to 0. Okay. Other homework questions just on this set, and then we'll look at the next one.
Could we do number 5?
Yeah. Because number 5 has a cosine of 2x and a cosine of 1x, I would originally just go and change the cosine of 2x. You've got 3 options for that one. So because of what else is in the problem, it kind of tells me what to replace that with, and I should do 2 cosine squared minus 1 for that. Keep your minus cosine. And then I would just put everything in order and factor as a trinomial. So if I just kind of shift things around, that means I can then factor as 2 cosine and 1 cosine. Factors of -1 would have to be -1 here and +1 there to add up to -1 in the middle. So that means you're looking for 2 things. Where does cosine equal -1/2? And where is cosine equal to 1? So first, if I look at where is cosine equal to -1/2, if I look in my chart, cosine's equal to 1/2 at pi over 3. But if I want -1/2, I have to think of my pi over 3's in quadrant 2 and then 3. So 2 pi over 3, 4 pi over 3. Cosine is equal to 1 only at 0, as we wouldn't include 2 pi because it's the same thing. We would not include pi because over there cosine would be -1. So those would be my only answers for that. Anything else on this page? No? All right, continuing on. Second set. These are the fun, like, gotta add a second rotation or a third rotation, depending on which one you're looking at.
Miss Heininger?
Yeah.
On number 3, it was just like one of the answers was 9/6. Do we need to simplify our answers?
Reduce that. Did I not do that?
No, you did. I just didn't know if we needed to.
I always tend to reduce. I don't know that I'm going to take off points for that because to me, that's something, I don't know. I would try to reduce. I just don't know how picky I'm going to be about that. So
Okay.
yeah. Anything, let's just look 1 through 6 right now. Anything 1 through 6 we're not sure about?
Can we do number 4?
Yep. So you have options when it's a cosine of 2x. If you're getting comfortable with like the where is cosine equal to 0 and then doing a second rotation around the unit circle and then dividing by 2, you can use that here. But if you're not real comfortable with that, with the cosine of 2x's, you can also replace the cosine of 2x. It really just doesn't work right for the sine. But if I wanted to replace cosine 2x with 2 cosine squared minus 1 and just solve that, I could, and that would be totally fine. For the sake of argument, I'm going to go ahead and show it as the other way, just so we're practicing that. So I would be looking for where is cosine equal to 0. So in my chart, cosine is equal to 0 at pi over 2, which means it's also equal to 0 at 3 pi over 2. But those are not my answers for x, those are my answers for 2x. So I know this is my first rotation around the unit circle. Because of the 2, I'm going to do a second rotation by adding 2 pi to each of those. So adding 2 pi to halves is really like adding 4 pi over 2. Pi over 2 plus 4 pi over 2 is 5 pi over 2. I do the same thing to 3 pi over 2, which gives me 7 pi over 2. And then I finalize my answers by dividing everything by 2 or multiplying the denominators by 2. So my 4 answers for this are pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. And I would get those same answers if I had replaced the cosine of 2x with 2 cosine squared minus 1. They would both work. What other homework questions do we have?
On number, let me see what number it is. Number 9, I think it was. You added a 4 pi after the, well, I guess we can just do it. But I guess, do you want us to go out to 2 pi on these either, or no?
Always out to 2 pi. So this one, if I FOILed out the left-hand side, that gave me sine squared plus 2 sine x cosine x plus cosine squared is equal to 1. Sine squared plus cosine squared equals 1. So I would subtract 1 from both sides to cancel that out. So then I have 2 sine x cosine x is equal to 0. Can't solve anything with a sine and a cosine in it, but that is a double angle identity. So I have sine of 2x is equal to 0. So then I can do the same process we've been doing. Where does sine equal 0? Sine is equal to 0 at 0 and pi. That's my first rotation. Because of the 2x, I'm going to do a second rotation by adding 2 pi to each of those. So adding 2 pi to 0 gives me 2 pi. Adding 2 pi to pi gives me 3 pi. I would then finish out by dividing all my answers by 2. So 0.
So
Yep.
on the t, it went 0 pi, and then for the second one, it went 2 pi, 3 pi, and then 4 pi.
Well, I did something wrong there.
Okay, so we don't need to go out like another one?
Nope, we are good. I may have continued out too far on that. No, always just go out to 2 pi. Yes.
Perfect.
Other homework questions? Feeling somewhat okay about this?
Mhm.
I mean, honestly, when you get going with all of the answers and stuff, it's not too bad. I did want to, I'm just going to find a blank space here, talk about the, at least the challenge problem, and then one other question from the quiz. So let me find that for myself. The challenge problem, some of y'all made it like super difficult. That's why I wanted to talk about it real quick. Others got really close to the right answer. I think I had 1 or 2 get all of the right answers. And when I say all, I do mean all. So that was just lovely. So the challenge problem was, let me find it. There were 2 versions of this as well. So I'm just going to do one because if you can do one, you can do the other. Just kind of applies that way. So cosine 4 plus sine 4 tangent 4 equals 2. Okay, so it was one of two different versions, but I'll do one of them. So cosine of 4x plus sine 4x times tangent 4x equals 2. Some people went after this like we did hard proofs where they made this like cosine of 2x plus 2x, sine of 2x plus 2x, tangent of 2x plus 2x. You can do that. But what I'd also like you to notice is that really the reason we use the double angle identities at all is when we have a sine of 2x and a cosine of 1x. Like when your x's, your angles don't match. On this challenge problem, one thing that you could notice is that all of the angles match, which means I really don't have to change out the 4x. I can just kind of roll with it. And by that, I mean, those who did get close recognized that you could make this tangent into sine of 4x over cosine of 4x. Whoops, not 0, 2. And then try to get a common denominator. The common denominator would be a cosine of 4x, so I'd multiply that top and bottom over here. That gives me cosine squared 4x plus sine squared 4x over cosine of 4x. What can I do with that then? Even though it's 4x's, what's that going to turn into? Anyone?
1, right?
Oh, going to be 1, yeah, because that's still the Pythagorean identity. So even though the 4x's are in there, you can treat that like a normal Pythagorean. So I have 1 over cosine of 4x equals 2. So that I'm going to use that flip trick again and just make that cosine of 4x is equal to 1/2. Now this is turned into one of the ones that we just did on our homework. So instead of trying to expand the 4x, I'm just going to say where is cosine equal to 1/2? Cosine is equal to 1/2 at pi over 3 as well as 5 pi over 3. However, those are not my answers for x. Those are my answers for 4x. What does that mean because of the 4x? How many rotations are we going to go around the circle?
4.
4. So technically speaking for this one, I'd have 8 answers. I'm not going to finish out all 8 because at this point, it's just a matter of adding 2 pi a bunch of times and dividing by 4. But that's how you would have done that challenge problem. And then the one other question I wanted to talk about from the quiz was your question number 6. It was one of 2 different versions, but either way, it had a denominator on it. Let me see if I can get this one down right. Sine times tangent over 1 minus cosine equals 3. Okay, so I'll just do one version of this. And to be fair, we hadn't really talked too much about this. So I did not take off points if you didn't do what I'm about to show you. So just be aware of that. This particular one was very similar to a homework question that we did, where we multiplied this over to this side and distributed. On the same step, I went ahead and changed my tangent to sine over cosine. And then I also went ahead and multiplied this cosine to the other side, which gave me 3 cosine minus 3 cosine squared. Then I changed my sine squared to 1 minus cosine squared. And I moved everything to one side and factored. So if I moved everything to the left, that would give me 2 cosine squared minus 3 cosine plus 1. I would factor as normal. And a lot of us got through this admirably well, which I was kind of proud of us for that. The problem comes at the end, and it's not something that you would actually expect. You're working through this, and I'm going to come over here to the side. You're looking for where is cosine equal to a half and where is cosine equal to 1. Here is actually the problem. Look back at the original problem. If the term cosine x is equal to 1, what is that going to give you on the bottom of the fraction?
0?
0, right? If that whole cosine x changes to 1, 1 minus 1 is going to give me 0. Are we allowed to divide by 0?
No.
No. So at this point, I got rid of that without finding any answers. We had not talked about that. This is just like when we did rational functions back in the fall, where you can't have 0 on the bottom of a fraction, but these are a little bit trickier to even think about because of the cosines and the sines. So I would watch out for that. Like I said, I gave credit if you had 2 answers for cosine being half and 1 answer for cosine being 1, because you got through it and solved it, and we hadn't really talked about that. I would just say for questions like these, if the original problem is a fraction, I would check to see if you get 0 in the bottom of the fraction from what you're doing, just so that you can be sure to eliminate those. So technically, on this kind of question, my answer is just where does cosine equal a half, which was pi over 3 and 5 pi over 3, and not any answers from the cosine equaling 1. I did want to talk about that before the test in case it does show up. It does occasionally. It's not common. As you've seen, a lot of the questions we've done don't have fractions in them. So I would just be cautious with that. Are there any things that y'all aren't sure about from the quiz or from other stuff from your homework or any of that? Yeah.
So is it like cotangent or cosine or secant where if you like set it equal to 0, you can't find the answer for it?
Those you can, because they actually have, like, there are answers that are undefined for those. Like, there are places that cotangent is undefined, and that's okay. It's really the sines and the cosines that throw us for a loop, with those being on the bottom of a fraction. Undefineds, though, get tricky because, like, the homework question we looked at on number 2, like, we kind of worked out to some answers where cosine was equal to 0. Well, that makes secant undefined. Can you really say that undefined equals undefined plus 0? I mean, undefineds don't really work in equations. So that's why we had to eliminate some of those answers. Really, honestly, and I'm not saying plug in all of your answers at the end, but it never hurts. That is for sure. Because if it doesn't make sense like that one, undefined equals undefined plus 0, then I wouldn't do it. Just like on that other fractional one, getting 0 in the bottom of a fraction is not correct either. So I would just be careful with some of those. Mostly it's really the reciprocal ones, anything that gives you a fraction. So something like question number 1 on this page, I wouldn't worry about at all, where 2 is a little bit different.
So if you got down to something like cosecant equals 0, would you just...
You can't have that only because if you get down, and that's not like this particular problem, but let's just talk about that. If I get down to cosecant equals 0, what does that mean for us with its reciprocal? That means sine is equal to what?
Undefined, right?
Is there anywhere that sine is undefined?
No.
No.
Oh, okay. So, but if you had like cotangent equals 0.
That's okay, yeah, because if I flip cotangent, so if I work out that cotangent equals 0, I can flip that because I do have a place in my chart where tangent is undefined. I don't have a place for sine and cosine being undefined.
Okay, so
yeah.
Cosecant and secant can't equal 0.
Right. And that's, again, because of the parent functions. If you think about, if you remember those were those U shapes. Did those ever touch 0?
No.
No.
Okay.
Okay. Other clarifying questions, things we're not sure of?
For an answer, it was like tangent square root 3 over 3. Would that be no solution or would that actually have an answer?
It does have an answer, and let me show you why. Remember how I said I am never going to make you simplify the radicals? Root 3 over 3 is actually the same thing as 1 over root 3. Because even though I am allowing you to keep it as 1 over root 3, what if I multiplied by root 3 over root 3, which is mathematically proper? What do I get?
Oh, root 3 over 3.
So those are technically the same things. This is considered to be the proper answer. We have always allowed you to leave them here, but you do need to know how to go in between those two.
Okay, thank you.
Yep. And that's where, like, I have a little bit of a difference of opinion. What I teach and how I teach it always depends on how AP Calculus teaches. And AP Calculus is very interesting about how they grade stuff. They are totally okay with you leaving something that's not like mathematically correct as long as it's an equivalent form. So that's why Napier has always said, like, I don't care if you leave it as 1 over root 3. I still want you to be able to go between the two because occasionally you will see the other version. Like the SATs and ACTs, if they do stuff with trig, they're not going to use 1 over root 3. They're going to use root 3 over 3. So it's good to know both.
Can we do number 11?
11 on what page?
269.
Yep. On 11, I would again replace the cosine of 2x because of this all being in terms of cosine on the right. I would replace the cosine of 2x with 2 cosine squared minus 1. And then just like normal, I would move everything to one side and I would factor. So I would move the 3 cosine x by adding it. And then I would subtract 1, which would give me minus 2. Factoring, I'd have 2 cosine x and 1 cosine x. I can't put the factor of 2 in this parentheses, so I'd have to put it here. And then I'd set my factors equal to 0. So I'd have cosine x equals 1/2 or cosine x equals -2. At this point, hopefully we recognize, are there any solutions for cosine equaling -2?
No.
So I don't include those. I just look for where is cosine equal to 1/2, which happens at pi over 3 and 5 pi over 3. Any other questions that y'all had for me? If you can do these homeworks, the review pages, like I said, on Canvas. Let's see, where did I put those? I did make a review assignment. I know I hadn't been doing that this spring, but with being online, I felt like it would be good for us all to have a review. They do have the answers included with them so that you can make sure that you're doing it correctly. That the review worksheets right underneath the review video that this will be posted on is the ones that we're turning in. And then there's the additional ones if you want more practice, but that's totally up to you. Whew. Anything y'all need?
Are there any questions on the review sheet that we're not supposed to do, like that we didn't cover?
I don't think so. That's where I feel like these were good sheets. No, these are all, they look pretty good to me. They're pretty straightforward as far as they go.
Ms. Leininger, is it the one that's like HPC trig equations worksheets?
Yep. So the answers to the bottom, or the first page are on the bottom, and the answers to the other page are on the bottom as well. I don't really need to see these pages. I would rather see you like upload your work. That's my preference on that, but yes. No, they're all good questions. I would say a lot of these involve factoring, like a lot, but I don't think that's bad. They all involve either factoring or substitutions of trig identities, which I feel like these tend to be, if I was like classifying these are not like the easiest questions that we've done because some of them are pretty straightforward. Like the first couple on your quiz were just like add something to the other side and divide and find where the cosecant is equal to this. these, the like kind of the rule of thumb on these, if you can solve like the quote harder ones with the factoring and substitutions, then the easier ones are just easy, you know? So I feel like these are a pretty good level to practice for the test. Personal feelings on that, but yeah.
Miss Leininger, I don't see the answers on the worksheet.
No, they're at the bottom of the worksheet for me.
Oh.
Yeah.
Okay.
Do you see them?
Mhm.
Okay, perfect.
But you said there was the review 8 trig identity in equations. Is that a review? It has like 8 pages.
Don't worry about that. That is old.
Oh, okay.
I think that's under our old Unit 8. I've kind of modified all of our stuff for online distance fun.
That one says it's on the Unit 8B review 420 and 421.
That's what is on there. Let me see. Oh yeah, let me get rid of that. I don't want that on there anymore. I will ditch that because that used to be like proofs and solving on the same test. Lots of fun. Basic.
Yeah, done with proofs.
Horrible. So, yeah. So ignore that review. I'm gonna get rid of that one. That's mostly proof stuff anyway, which is why I'm kind of ditching it. There are things there, but I don't feel like it's necessary to go searching through it, and everyone will probably just get confused. So,
I have a question.
Yeah.
On page 266, we solved number 2. The key said pi over 2, but when we solved it earlier, you said 3 pi over 2. So
What did I say? I don't remember now.
because
I think I said the wrong answer there when I said it. That I worked out to cosine. What did I work out to? To 1.
the sine equals sine squared plus cosine squared, and that turned into 1.
Yeah, then I said the wrong thing. It should have been just pi over 2.
That's
My key is actually right on that one. I'm a genius some days. Whew. Anything else that y'all need?